This is how many runs they have scored in their season so far. But we have one more, and we don't know what it is. So let me tell you what not to do, and this is probably the first thought that a lot of people had, and it used to be my first thought as well. So here we go. They scored these runs. There's one more game in the season. If the team wants to end the season with an average of at least 6 runs per game, and a lot of people will stop right there, and they'll say average, and they'll average these. Don't average these, because we need to average these. We have one more, and we don't know what it is. And so we need to average everything, even the one that we don't know. Well, how do we do that? Well, that's where variables come from. We have one more. So here we go. What is that one more? Call it what you want. I'm going to call it N. Call it R for run if you want to. We want to have at least 6 runs per game. What's the least number of runs the team must score in the final game of the season? So there are 2 ways of doing this. Given the answer options, we can plug them in and average them that way, and that's horribly inefficient. It's very inefficient. So we could, like for instance, choice A, we could put a 2 right there, and we can average it and see if it gives us 6 runs per game or more. We can do the same thing for 4 and for 6 and for 8, but we also need to keep in mind that we're going to find the least number of runs the team must score. So it's possible that more than one of these answers will give us at least 6 runs, but we need to find the lowest one. So if we go in order, we can find it, but let me show you a faster way. Let's average these numbers together. We're going to average them. So 6 plus 2 plus 5 plus 9 plus 11, 4, 5, 8, 6, 7, 5. That sounds like a song. 8, 6, 7, 5, 3, 0, 9. Divided by, well, how many things do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 things. And we want it to be at least, what, 6? We want to have at least 6 runs per game. So now when we're going to have at least 6 runs per game, then we're going to have 6. Now, keep in mind, at least doesn't mean less than. That confuses the mess out of people. I remember when I was student teaching, they struggled with that. We beat that into them for 2 weeks. Bless their hearts, they didn't get it. If I'm going to give you at least $6, then I'm going to give you $6 or more. Okay? It's one of those little language things that we got to be careful about. Greater than or equal to 6. So we're going to average that. It's going to be greater than or equal to 6. Don't panic when you see this mess. Let's do 2 steps in one. Let's multiply by 12. It's going to get rid of that denominator. Multiplying by 12. 6 times 12 is 72. Put it there. Man, that is getting sloppy. And then we'll simplify the numerator. We have n plus, and then whatever it is when we add all that stuff. You know, I was about to do it in my head. Let's not. Probably should, but I'm not. 6 plus 2 plus 5 plus 9 plus 11, 4, 5, 8, 6, 7, 5, 3, 0, 9. 8, 6, 7, 5, 3, 0, 9. That's how you get a hold of Jenny. 68. 68 plus n is greater than or equal to 72. I obviously had a font change halfway through that. We're going to subtract 68 from both sides. Subtracting 68 from both sides gives us n greater than or equal to 4. Now you might be thinking, you did not show us this at the beginning of the semester or at any point in the semester. We did review a little bit at the very beginning of the semester, and knowing that we reviewed, we solved some equations in there, and I would like to think that you could solve this because we've done this kind of stuff. Maybe not within the context of this type of problem, but we've done this. So n is greater than or equal to 4. So that pretty much gives you the answer, which means any number greater than or equal to 4 will work in order to get an average of 6 or more. So this number needs to be 4, 5, 6, 7, 8, 9, 10, 11, count on and on and on and on and on forever. But for 4, that would mean the answer choice is D.